Good afternoon. Welcome to the Water Talk seminar. Today's speaker is Malcolm Edwards, a soil and air management specialist with the Medicine Bow National Forest stationed here in Laramie. As a way of background, I'd like to point out that Malcolm's been with the Forest Service for the last 14 years, and he's been moved around the western United States. He's served in several states and several of the national forests. He's been involved primarily with mapping, interpreting, and applying soil and vegetation surveys on what turns out to be over 3.5 million acres in the western United States, covering a range in elevation from 1,000 to 13,000 feet. That covers most of Wyoming. So my pleasure to introduce our speaker today, Malcolm Edwards.
Thank you, Dick. As Dick mentioned, this is a talk on ecological surveys, which are field data collection systems that integrate the soils, vegetation, landforms, climate, and a variety of other things into a classification system and present that data in a user-friendly information system to your users. It does have a variety, this data does have a variety of uses, and it's a good once-over survey. If you had only one survey you had to rely on for the management of your lands, this would be a good one to rely on. Everybody see that all right? That a little bit light?
Tell them to dim the lights and the booths back there.
Well, many of you are now or will be working in natural resources in your career, and some perhaps in fisheries, watershed, or other resource management areas. Perhaps some of you may ultimately just end up being interested publics in our natural resources. What I intend to share with you today is a very useful tool that can be applied to wise land management and the decision-making process for our national heritage of forests, woodlands, prairies, deserts, and wetlands. Just for your reference, as I go through this talk, I'll be referring a lot to, of course, our forest here, the Medicine Bow, and probably most of you are familiar with it. The main part of the Medicine Bow, we're here in Laramie, the Pole Mountain area. The Laramie Peak Unit, in here about 450,000 acres, of which about 60% is private lands intermingled with forest lands. And our Thunder Basin grasslands, this large unit here and the smaller Spring Creek unit there, those again are over half private lands intermingled with the national grasslands in there. Presents a challenge to management with all that private land intermingled. That gives you an idea of what the setting is I'm talking about here. Ecological surveys is used by the Forest Service and other land management agencies such as the Bureau of Land Management, the Park Service, and some of the states, are an inventory procedure and classification of the soils, the potential vegetation types, various landforms found throughout the forest, and the geology or parent materials of the soils, the climates, and then the resulting interpretations that we use for managing those ecological units. Our Washington office direction found in our system of manuals, that's what the FSM is, Forest Service Manual, in this case the 2060 manual, gives a direction to provide a survey with a unifying ecosystem framework and to stratify land and resource production capabilities and what actually happens when we manage these ecosystems. And by management, I do mean anywhere from wilderness or a research natural area, which is actually no management, to timber harvest or grazing systems, even campgrounds, and other developed recreational areas. I realize these statements probably seem a bit bureaucratic and vague, but I think you'll understand what we're referring to as we go along here today. That's got to be hard to see. There we go. Now I can't see my notes, okay. Anybody got a cigarette lighter here or something? Well, ecological surveys are sometimes known as by other names. Soil surveys is what we used to call them, and some states are still using just soil surveys. Soil resource inventories, pretty much the same thing. Nowadays we're using the term ecological survey. Some of the other terms other areas are using are modified equal class collection systems and terrestrial ecosystems. They all refer pretty much to ecological surveys. There we go. Generally, the ideal overall scale we use in mapping ecological surveys is the 1 to 24,000 scale. That is, 1 inch equals 24,000 inches on a map. That happens to be the geological survey scale they use on the topographic maps that we all use in resource quite a bit, and for even backpacking trips and such. Let's start off by talking about the basis of the surveys, and that is the soil and vegetation components. This is a slide of one of the aerial photos, type of aerial photos we use. As I stated before, this is a 1 to 24,000 scale, which is generally accepted and used all over the United States. Standard color aerial photography are used as the basis for the field data collection. It's quite easy to locate yourself within, anywhere from 20 to 40 feet out there in the landscape using these aerial photos in stereo photography. And they quite readily transfer to USGS scale 1-to-1 basis, being the same scale. Initially, the ecological unit polygons, such as you see here, are drawn on the aerial photo based on homogeneous looking vegetation types such as the spruce fir or ponderosa pine or lodgepole pine in our case. The landforms such as riparian areas, or otherwise known as valley plains, hills, mountains, and other features are also incorporated into these polygons you see here, as well as the range of the slope percentage. The lesser slopes being in the 0 to 10% range, moderately steep 10 to say 40%. Anything over 40% we consider steep or very steep. Obvious changes in the geology type or the vegetation show up quite well on these polygons when you do view them with aerial photography, with a stereo component. Taking it another step further here, each identical ecological unit or polygon is represented by the same map number or symbol in this example. The ecological units have the same soils and vegetation types and occur roughly in the same position in the landscape. And then the fun part begins, the actual field data collection. Good old hard work. And if you're lucky, you have a backhoe to help you dig these pits, or at least a couple of helpers. The soils are examined in the field quite in detail and classified according to our National Soils Taxonomy. Representative soil descriptions are taken for each of our vegetative types. In this case, you see the spruce fir there in the background, and our aspen type. The soils, as I mentioned, are classified according to the National Soil Taxonomy Handbook and assigned a common name, or what we call a soil series name. In this case, if you can see that, it's called the Frisco series. The cobbly loam in the name here, referring to what's on the surface of the soil. It's a cobbly soil with a loam texture, the 10 to 25% slope range. And then the plant association. Here it's Pinus contorta, Vaccinium scoparium. And I'll make a little note here about these vegetation codes if you're not familiar. We take the first two letters of the genus and the species and combine them, as we've done here, Pinus contorta and Vaccinium scoparium. And that presents a unique code for that plant species. If there's another plant somewhere in the United States with that same abbreviation, you can attack a 1 or a 2 or a 3 and so on behind the plant code there. On a very general scale, our vegetation types within the medicine bow are shown here. Starting at our lower end, generally below 8,000 feet, we find the Pinus ponderosa or ponderosa pine and sagebrush type. Moving up the elevational scale there, between 8,000 and roughly 9,500 feet, the lodgepole pine type. Above 9,500 feet, the spruce fir type. And when you get to about 10,500, we start getting to above tree line into the Krumholtz, which is characterized by stressed, brushy-looking spruce and quite an array of forb and grass understory in there. And at about 12,000 feet, that's the upper elevational limit of our forest in this case. Representing one of our lower elevational units, our sagebrush type, very common throughout the West. It runs all the way from central New Mexico well up into Canada. This particular picture was taken on our Spring Creek unit. That's a little part of the grasslands way up there by the Montana border. This elevation is about 4,200 feet. And sagebrush can occur with a whole variety of other grasses and forbs. Blue grama, crested wheatgrass, or western wheatgrass are some of the common grasses you find with sagebrush. This picture was taken last spring, just as we were getting our spring rains, and things were greening up pretty nice, and it was beginning to look pretty nice out there. While much of Wyoming was suffering from drought, this area up here seemed to be getting more than its fair share of rainfall. Moving up to about 6,800 feet to 7,000 feet, our ponderosa pine type. Most of our ponderosa pine types found on our Laramie Peak unit. Very little actually on the main part of the Medicine Bow here. And our lodgepole pine type. This is our most common type of forest. This particular picture was taken in an elevation at about 9,100 feet. And moving further up the scale, the spruce fir type, Engelmann spruce subalpine fir, with quite a vaccinium understory in here. And this picture was taken at about 10,100 feet. And of course, culminating at Medicine Bow Peak, which is just barely over 12,000 feet. And as I mentioned before, once you get about 10,000 feet, we start running above tree line, and you get into this Krumholtz, what we call Krumholtz type of vegetation here, with a really stressed out spruce, quite a variety of forb grass understory in there. Due to the severity of the climate and a lot of wind up there, these spruce never really quite take off, and they stay like this for decades and decades, hundreds of years actually. And the Medicine Bow Peak, mostly barren, just rock outcrop, very little growing up there. You do find some dwarf willow species growing in snow concentration areas on slopes like this. For the most part, it's barren. That's just a little over 12,000 feet. On our grasslands, in the riparian areas, we also sample for soils and vegetation information. This being our plains cottonwood type within the grasslands. This particular creek is Antelope Creek, the understory being quite a bit of green needlegrass, western wheatgrass, and some bluegrasses, and needle and threadgrass. This being some of our higher elevational riparian areas. This particular type is characterized by a lot of standing ponded water moving very slowly, a high buildup of organic matter in what we call organic soils or histosols. And vegetation is characterized by Carex equatalis, which is a water sedge, one of the willows, Salix planifolia, some Dischampsia, which is tufted hairgrass, and Caltha, which is known commonly as marsh marigold. Very common species you find in this type of zone. Now, for our sampling of our vegetation, we use Dobenmeyer, what we call Dobenmeyer plots, developed by him. Basically, two types are line transect method, which will take you somewhere around 4 to 5 hours to complete, It's a very detailed method. You lay out 2 line transects with a quadrant, sample your vegetation and the canopies. That's roughly 15 meters by 25 meters. We use that to standardize our ocular estimates out in the field. And every time you lay down the quadrant frame, every so many feet, you make an estimate of the amount of rock and litter and bare soil and canopy covers of all the plants, and record that information and do that somewhere around 40 times and average that information and come up with quite a good representative numbers for all your plants and other components. We have a recon plot, which after you have calibrated yourself using the line transect method there, you can pretty well estimate your canopies of your plants and other story and other components using a 36-foot radius recon plot. Some of the vegetation information we gather, and this is a simplified example here, would look like this with the plant codes on the left there and the percent by canopy cover there on the right. The P there in Juniperus communis, or dwarf juniper, the P refers to just present. It's in the area, but it was not within your plot. And the plus plus referring to just trace amounts, usually less than 1%. Is that in focus? A potential natural vegetative community, which is the areas we aim to sample, are characterized as being the endpoint of succession in this stage of its life, enduring and stable and with a relatively small rate of change. Riparian areas occupy specific landforms, what we call valley plains. They do have aquatic ecosystems, maybe perennial or ephemeral, contain hydric soils, and are protected from entry, most of the time in timber cells, to at least 100 feet either side of the stream, in what we call a buffer strip. Sometimes we can enter riparian areas and manipulate the vegetation. That's usually for a management objective, such as trying to regenerate the aspen to encourage the beavers in the stream. But normally we don't touch the riparian areas. Hydric soils, these are defined as saturated, flooded, or ponded soils. The organic soils, which we call histosols, and those soils showing any evidence of excess water during at least 3 months out of the year. In our plant classification, oftentimes we will put a label on a plant association as to what type of climax it is. Some of the terms we use here are edaphic, which would refer to a plant climax that was growing in a other than normal type of soil, such as out here in Wyoming, quite often you see these really brackish looking little lakes out in the plains with high sodium content. Though they will grow certain types of vegetation, such as, greasewoods will grow out there. And we classify that as an edaphic type of climax. A topographic may be, a riparian area is an example of a topographic climax, or an extreme south-facing slope. Pinus flexulis is a species that commonly grows on steep south-facing slopes on the forest. A fire or other disturbance type of climax may be characterized by mountain mahogany or gamble oak or some of the other species. Zootic, which has been disturbed over long periods of times, sometimes by cattle or man, or indirectly by man. And then climatic climax, which is a so-called normal situation, a good deep loamy soil with pretty much standard vegetation, such as our spruce fir or lodgepole pine. What we look for out in the field to give us an indication of what kind of soil we're looking at, and also the climate, is some soil vegetation relationships. There are certain species of vegetation which indicate some things characteristic about the soil. In this case, our Artemisia arbuscula nova, which is black sage, is usually a pretty good indicator of a shallow soil. The Idaho fescue indicates at least 16 inches of rain, of precipitation. Our sagebrush, Artemisia tridentata, generally likes a salt-free soil. That is a soil with very little electrical conductivity. Yucca species generally prefers sandy sites. Our Vaccidium scoparium, in general, prefer a low base topsoil. That is a soil with relatively small amounts of the bases. And Dischampsia, which is tufted hairgrass, is usually a pretty good indicator of a water table or excess water somewhere in the soil profile. Of course, you can always find exceptions to these, but in general they fit pretty good, somewhere around 80-90% confidence there. There's all kinds of these you can come up with throughout the West, the soil vegetation relationships. These are just an example, just a handful of quite a number of them. Productivity, while we're out in the field, the productivity measurements are taken for the trees, and one of the best measurements of that is site index, or the height of the tree versus the age. And comparing the two to a chart, you can come up with what we call the site index. We also measure that in the growth per year as cubic feet per acre per year. The forage producing capability is estimated by actually clipping or sometimes just estimating what the pounds per acre production potentially is on a given soil. And we do that by either clipping or ocular estimates, what you've calibrated yourself. And we do it for both under seral conditions, seral vegetative conditions, and climatic conditions. We try to build a climatic gradient. This is using actual station data from the Water Center and also Martner's book on the Wyoming Climatic Atlas. And I plotted a few selected points running from Centennial down here at the lower end, just around 8,000 feet, up to Brooklyn Lake, somewhere in the high 10s or low 11,000 feet. Plotted these points and had the computer draw a XY linear regression there, and try to come up with some kind of a sense as to what the precipitation is versus the elevation. In this case, it fit reasonably well there. We also have in soils what we call soil moisture regimes and soil temperature regimes. These are an example of some of these we find in Wyoming. In the ponderosa pine type, we find the ustic soil moisture regime, which is generally water deficient over much of the year. In a frigid soil temperature regime, which as the name implies is kind of a moderately cool temperature there. There are specific numbers attached to these terms I'm using here. The HYDRIC moisture regime, a little bit wetter. We're getting wetter as we go down here. Usually water is no problem. There's always at least enough for the plants to grow and perhaps a little bit of excess. And a temperature regime, crike, indicating pretty cold. The mean annual soil temperature is just kind of hovering a little bit above 0 degrees centigrade, in other words, freezing. And our vegetative indicators there are the lodgepole and the spruce fir type. We get into riparian areas, obviously the aquic referring to a lot of excess water. That can run the gamut of soil temperature regimes, frigid crike, down even into thermic, which is what we find in, well, like in Arizona, in the lower elevations. Some of the indicators there are the alnus or elders and some of the willows or salix species. We also make notes of the landforms, such as the valley plains. Valley plain being a course for water to run through this area and here. Some of the hills and mounds that you find here off to the left of the photo, and of course the mountains there in the background. And we classify those quite easily using keys on the vegetation. Try to keep it simple. Just call it a mountain or a hill or a plain. Call a spade instead of trying to come up with the long fancy names. People relate to it a little better. I don't know why I put that in there. Okay. To wake you up, I guess. You know, we may start seeing these things like the wild horses and burros there in the southwest. Some of them 100 years ago got loose and started breeding, and now, of course, they're protected. And any more people using llamas to backpack, I expect some of these may get loose and start breeding them out in the wild, and we'll have a wild llama protection act here one of these days. The data in the maps are then interpreted and presented to the users. This is an example of one of the ways we may present this information. I'll run through this kind of quickly. The map symbol, the symbol that you're finding on the map, refers to some certain information. The map unit name, in this case there's two different soils occurring in there, Agneston and Blacklead, on a 10%, 0 to 10% slope range. The composition is roughly 50% Agneston soils and 35% Blacklead family of soils. Any inclusions you want to mention in there? Some of the setting and environmental factors that you see here. The landscape, where does this soil unit, ecological type, occur in the landscape? At what elevational range? In this case, 9,500 to 10,500 feet. The vegetation, spruce, fir, vaccinium. Some of the other factors, the organic matter content in the surface. What's the texture of the surface and the control section, which is a subsoil? How deep is that soil? This one, particular one's moderately deep, which means 20 to 40 inches before you hit bedrock. The drainage class is well drained and dendritic drainage pattern. Permeability is moderate, runoff is slow. K factors refer to the relative erodibility of the soil when exposed to snowmelt and or raindrop impact. The T factor, which is a tolerance, and how much, at a maximum basis, how much soil loss could you accept on that particular soil unit? 3 tons sounds like a lot. And of course, if you saw it all in one pile, it would look like a lot. But actually, when you go out there on the ground, it's actually very much thinner than a dime, 3 tons per acre. And that's not something we shoot for. That's the maximum allowable. Anything above that 3 tons per acre per year, it's eroding faster than the soil can rebuild itself. And the precipitation for the unit, the soil temperature, the frost-free period, in this case, pretty cold soil, less than 20 days. I wouldn't count on trying to grow any crops there. Some of the interpretations, we take this information and crank it through some programs or charts and graphs and come up with interpretations for various uses. Some of the examples here, revegetation, reforestation. Any limitations you might have for management activities such as timber harvest, cut bank stability if you were to build a road through it. How that material, the salt material, would hold up if you were to build a road on it, an unimproved road. Trails, campgrounds, wheeled off-road vehicles. If you had to use this particular soil as a source for topsoil or road fill or even earthen dams, how would they function under that use? Any hazard potentials you might feel are existent in that ecological unit, such as wind throw, that's the susceptibility of the trees to being blown over by wind. It has a lot to do with the depth of the soil, the texture of the subsoil, and also the location and the topography. Some slopes are more exposed to wind than others. Mass wasting, which refers generally to landslides, debris flows, that type of thing. Sheet and rill erosion. What's the minimum, the tolerance percent ground cover, that's the minimum ground cover you'd want to have on that soil, or you'd exceed the tolerance soil loss. Again, that's not a target we shoot for. We want quite a bit more, over 10%, but that's the absolute minimum. In other words, if you were to disturb that soil and try to reclaim it, you immediately want to try to get at least 10% ground cover back on that soil to protect it. And the soil productivity, the timber species, whatever species are occurring on there, in this case, Pinus contorta and Engelmann spruce, having a site index of 45, and the lodgepole a site index of 65. The forage production potential, in this case I didn't have enough information to put an exact number down, such as 1,000 pounds per acre, so I just rated it high, which would refer to it being able to produce over 1,000 pounds per acre in this case. what we call the engineering indices. These are soil mechanics or soil physics. If you engineers like these figures, the unified classification, that's an engineering term. Liquid limits, plastic index. Those are pretty much terms they use in engineering for the strength of a soil or the ability of a soil to withstand pressure from above. And you can make any management considerations you want to about the ecological unit. In this case, I mentioned something about the pH is about 5.6 on the surface, 6.0 in the subsoil, and any other comments you want to add there. Nowadays, much of the information that we gather will be available on geographic information systems or map overlay statistical systems and Oracle type databases. Geographic information systems are a whole subject in themselves. I won't cover them much today, other than to mention that the Forest Service is now deciding exactly what systems we want to use, and we should be getting those here in the next couple of years or so, something like that. And hardcover copies of reports, much like we used to see, may be a thing of the past. This is a draft report I wrote up last year for the main part of the Medicine Bow, the Laramie, Brush Creek, and Hayden district. It's about almost to the point of being published, but we may see the end of these hard copy reports and go strictly to electronic information. Let's cover some of the uses and applications of ecological inventory such as we've seen. We, of course, are a multiple-use land agency balancing a number of activities on the forest lands. Some of these land uses do involve commodity production, such as timber harvest or grazing of domestic livestock. The ability of the land to sustain these activities and to what extent they can is one of the primary uses of the soil and vegetation information. Just what is the forage producing potential of a given ecosystem for wildlife and domestic livestock, or where are the most productive harvest areas, and what slopes out there in the forest can sustain mechanized entry without unacceptable erosion and compaction. Where are the roads best located when we do need them, and what areas should we just leave alone? In the area of emergency burned area rehabilitation, using the existing soils data information, we can determine after a fire which areas may need seeding or other measures to stabilize the soil until the natural ground cover is restored. Just on one fire alone, this was the Clover Mist in 1988 adjacent to Yellowstone, one of the biggies that you read about most of the summer. This was a critical watershed due to the soils being pretty unstable, a lot of susceptibility to landslides and debris flows. A lot of these toe slopes were actually old debris flows in there. What we did was, over the course of all the critical watersheds that we identified, which was about 22,000 acres, somewhere in there, we put in about $1 million worth of emergency rehabilitation measures. And it did do a little bit of good. There's really not much you can do to hold back a massive landslide or debris flow, but we did do what we could to prevent surface erosion on these critical watersheds. Another burned area, this one was the Rochelle fire up on the grasslands a couple of years ago. This aerial seeding project, it was seeded by use of a helicopter. It was reasonably successful in germinating. A lot of the seed did get washed into this little ephemeral drainage here, as you can see. But quite obviously, I think it does show where it did help to hold the soil back on the slopes until the natural vegetation did reestablish itself. This particular fire, we seeded about 1,000 acres using some of the real common species that we do use for burned areas, such as cereal rye or annual rye, some agropyron or wheatgrass species, and a type of clover. Another use of our information on timber sales. In this proposed timber sale area, this is still undergoing the environmental process here, called the Cedar Rank Lay over there by Kennedy Peak, if you're familiar with that area. We took some of the soils information, both existing and new material that I had gathered, the hydrological data and some old geological mapping, and put it together and came up with an interpretive map there. The green areas being land areas with acceptable low risk for vegetative manipulation. The blue areas, previously identified landslide areas, and the red areas that had unsuitable soil or watershed conditions that if they went in there and disturbed that, there'd be a good possibility of flooding or stream damage or even landslides. So it's a very direct example of what we use this information for. Took a real chance putting this one on the screen, Mountain Meadows. Probably all heard about that one. Environmental documents that outline alternatives for a proposed project and the expected impacts from each alternative are outlined in an environmental impact statement or an environmental analysis. The alternatives for a proposed action are derived from both public and agency comments and issues. The ecological information can be used to alter or even drive some of the alternatives in a proposed action. Coal mining. On our grasslands, it's a pretty large activity there with actually four reasonably active coal mines. This one here being the largest, Thunder Basin Coal Company. They lease about 7,500 acres out there on the grasslands for their coal. Have a capacity or permit capacity of about 30 million tons per year. And a lot of these coal seams, I'm not sure if you can see that too well in the background, these coal seams are running anywhere from 100 to 200 feet below the surface, and they're actually about 70 feet thick, quite a bit thicker than a lot of the coal seams we find back east. The soils information is vital to the rehabilitation of these areas. What they do by state requirement is stockpile the topsoil anywhere from, well, whatever topsoil is out there, anywhere from 6 inches to say up to 5 feet. They'll actually push that aside and put a sign on it that says do not disturb topsoil, and leave it there until they're ready to rehabilitate the area. When they're done mining the coal, they push back the overburden or the subsoil and smooth that out, try to contour it to look somewhat natural, and then put the topsoil back over that and seed it. And that's what they're doing here, is hydromulching it, which is a form of seeding. It's kind of a wet seeding mixture with the grass, a little bit of fertilizer, and some tack agents in there to hold it on the slopes. Generally, I'm pretty impressed with what the coal mines do with their rehabilitation. It's fascinating to go out there, and they will let the public go out there on a guided tour and see some of these areas in the summer. It's worthwhile to do that with some of these large coal companies, just to see their production facilities and how it works, and the size of some of the machinery they use. The electro-haul trucks and the tires alone are 11 feet tall, about as high as this ceiling here. Just monster equipment. It's astounding to go out there and visit these areas. A little bit on biodiversity. That's a term we hear more and more nowadays. And ecological surveys will play an important role in determining what the baseline conditions and biodiversity is in our national forests. Our research natural areas, the RNAs there, contribute to the conservation of biological diversity. We do have one research natural area on the forest now. It's called the Snorri Range, and we have 2 more in the planning stages. Of course, the Multiple Use Sustained Yield Act of 1960 provided that the forest would be managed for multiple use and a number of different uses, such as recreation and grazing, watersheds, water supply, and timber. The Endangered Species Act provided for conservation of threatened and endangered species, whether that be animals or plants, and the ecosystems upon which they depend. And the NFMA of '76 required an integrated land and resource management plan, which we do have on the Medicine Bow at this time, for our forests and grasslands. And it was to provide for goals of plant and animal diversity and even old growth. And speaking of old growth, some of the characteristics we look for in that, the ecological surveys can identify just what areas are old growth and some of their vegetative characteristics. Old growth being the late successional stage of trees, uneven spacing and size class, large woody debris, whether standing dead trees or laying on the ground, and not just in isolated patches, but these old growth areas should be woven randomly throughout the landscape. The Medicine Bow, as an example, in our forest plan, we have an old growth retention of about 77,000 acres. And that's a minimum. And also, we manage for a minimum of 10% of each of our fourth order watersheds is planned to be retained as old growth in at least 30-acre or larger patches. As you know, old growth is certainly an issue that's come of age here recently. The surveys will also identify fragile landscapes, such as this one here at Libby Flats, up there in the Medicine Bow Mountains, where off-highway vehicles, as you can see, had started making their own way through the road. This being the old road here, it had rutted out and gotten pretty rocky, and you really couldn't travel it without wrecking the bottom of your vehicle. So people kept going around, and that just kind of turned into a cycle, and they kept moving over and over. This being the Krumholtz type vegetation, it's pretty fragile. You disturb something like this, and it takes a very long time for it to recover. What we did do last year was try to repair some of this damage and keep people on the original road and try to get back some of the these newly created roads, get them back into natural vegetation there. And a little bit on the subject of carbon or global warming, carbon dioxide in the atmosphere. You know, what does happen to the carbon in the plants and the soils when we disturb an area? Quite a bit has been written on a global basis about what's the cause and effect of global warming. We actually don't know very much on a micro scale as what is the effect of cutting trees on overall global warming. We just don't have a good handle on that. More research is planned this year and the years coming to try and determine that. Older type growth that you see here kind of in the background actually serve as very good carbon storing units. And actually the soils do too. They'll store quite a bit of carbon for long periods of time. Looking here at this chart, surprisingly, most people offhand would think that most of the carbon is in the trees, but actually on a national average, most of the carbon is stored in the soil, roughly 2/3 of it. Just under 1/3 of the ecosystem carbon is contained within the trees, and then the remaining small percentages in the litter and the understory growth. That's a little bit hard to see. This is a picture here of some young growing trees in the age bracket less than 50 years old. But my point is that young trees like this, a number of years after harvest, are good sequestering units for carbon. They'll take carbon out of the air, roughly about 830 pounds per acre per year. And just a little plug for the profession here. Soils are the basic resource in anything we do out on the land there. It is the base layer of all our management activities. And that's pretty much all I had.
Any questions for Malcolm? If you'd like to ask a question, please press the red button.
Yeah, Dave?
Yeah, Malcolm, how do you take 30 acres as an old growth size?
I was not here at the time when they decided upon that. I'm Not sure I can quite answer that. But, so I won't answer it. Okay, I could look that up. I'm not quite sure why they picked that 30 number. Next question that I can't answer.
Malcolm,
Dave.
are all the various inventories, range resources and the timber, all using this one system now that you talked about here in your program?
Okay, well, we have a whole number of inventories going on. Nick Schmall has his stream inventories going on, which pretty much measures the mechanics of the stream, the sinuosity, that type of thing. That information can certainly tie in with the information that I gather. We have what we call stage 2 inventories, which deals with volumes and growth of timber out there in the forest. And we have ecological surveys, which pretty much, besides detailed soils information, we'll take a little bit of each one of these other surveys into account there. But yeah, we do have other surveys going on. The main part of the medicine ball, which you saw the picture of there earlier, that's pretty much all finished. What I have left yet to do this year is about 120,000 acres on the Laramie Peak unit. And we'll be contracting that out, and I'll be the inspector and the contracting officer's representative on that contract to gather the ecological survey information. Yes, ma'am.
When you mentioned stage 2, made me have images of that big scar up there. And I wondered what you had done in terms of evaluating that soil before that project was undertaken, and also will it recover and how will that happen?
Yeah, you're referring to the stage 2 pipe water transmission line there. Yeah, you have to draw that distinction. There's a stage 2 tree or timber inventory, and then there's a stage 2 water transmission line, which was initiated by the city of Cheyenne a few years back to get water into the city of Cheyenne. Quite a large project. In answer to your first question, will that recover? Generally, I don't think it'll ever look natural, but I think it'll recover to be stable from a soil erosion standpoint. Okay, and yes, soils information was used in that. I've been here on the Medicine Bowl about 1.5 years, so I wasn't involved in that initial part of the stage 2 water transmission line. But they did come up with, based on soil types, recommend a minimum depth of topsoil on top of the overburden where they buried the water pipe. So that, yes, that information was used.
So is what you're saying that with the information that was taken in, that the decision was made to go ahead with it, knowing that it would always end up looking scarred like that and wouldn't look natural when it was finished? I mean,
that's correct. That's a water line in there, and they've done a good job of re-vegging that area with grasses and excelsior matting. Have you seen the area? Looked at it recently? Okay, that's recovering from a stability standpoint pretty good. There's not going to be old growth growing on that water transmission line. They don't want the roots getting in there and undermining the pipe that they put in there. So it's going to look like a road in essence. Yeah. That it?
Well, one more.
Okay.
I have one I'd like to ask. How successful do you think these ecological surveys have been on national forest lands in terms of predicting other environmental resource characteristics that aren't a part of the classification scheme? For instance, predicting fisheries habitat or water quality, this sort of thing.
Okay, well, that can vary. They can be used in the sense if you're concerned about water quality as far as sedimentation in the stream, on the watershed that surrounds that stream, we can identify how much ground cover is needed up there to prevent sedimentation of the streams. Does that kind of answer your question? Is that what you were getting at there?
That'd be one possibility, yeah.
Okay.
Because I know there have been efforts to use these to predict other resources, and I just wondered if you were familiar with those, what was your assessment of that?
Yeah. Well, and to answer that question, we're still working on that particular application. Fish habitat relations is one of them. We're still working on that, yeah. But I believe it will. Yeah. There's certain geological types, of course, lend themselves to certain stream sinuosities, and gravel and cobble size in there too. Well, thank you.
Okay, if there are no further questions, thank you very much, Malcolm.